Imagine walking through Earth's past and discovering something remarkable. Throughout history, different animals kept turning into creatures that look like turtles. This isn't just a coincidence, it's one of nature's most fascinating patterns, showing us how similar solutions can emerge when animals face similar challenges. Let's explore this incredible story of repeated innovation in evolution. When we think about turtles, the first thing that comes to mind is their shell. This distinctive armor, made up of a top shell, carapace, and often a bottom shell, plastron, sets turtles apart from other animals. But being turtle-like involves more than just having a shell. These animals typically have wide, flat bodies, specialized limbs that work well both in water and on land, and often develop beak-like mouths for specialized feeding. This combination of features has proven so successful that nature has recreated it multiple times throughout Earth's history. Why history repeats itself? Before we talk about the various turtle-like creatures that have evolved, we need to understand why this happens. Scientists call it convergent evolution. When different species develop similar features because they face similar challenges in their environment. Think of it like inventors coming up with similar solutions to the same problem, even when working independently. In nature, certain challenges appear again and again. The need to protect oneself from predators, move efficiently through water, or access specific food sources can lead different animals to evolve similar body shapes and features. The turtle design has proven to be an excellent solution to these challenges, which is why we see it repeated throughout evolutionary history. The story of true turtles begins approximately 260 million years ago, during a time called the Permian period. Scientists discovered fossils of a creature called Unitosaurus, which showed the first steps toward becoming turtle-like. This animal had unusually wide, flat ribs, the first hint of what would eventually become a shell. While Unitosaurus wasn't yet a true turtle, it gives us valuable clues about how the turtle body plan first began to develop. About 20 million years later, during the Triassic period, an animal called Papacholes appeared. This creature represented another important step toward the turtle design. It had even wider ribs than Unitosaurus and thick bones on its belly, showing more progress toward developing a shell. Papacholes probably lived a semi-aquatic lifestyle, comfortable both in water and on land, much like many modern turtles. The next major milestone in turtle evolution came with Eorhynchoucheles, which lived around 228 million years ago. This animal was particularly interesting because it showed a mix of features. It had a beak-like mouth, but still retained teeth in the back of its jaws. Scientists found its fossils in marine sediments, suggesting it lived along ancient coastlines. It likely used its strong limbs and claws to dig in the mud, searching for food both on land and in the water. Surprisingly, before true turtles had fully evolved, other groups of animals had already developed turtle-like features. This is where our story gets really interesting, as we see the first examples of convergent evolution in action. The saurophargids were a group of marine reptiles that lived during the early Triassic period, about 250 million years ago. These animals developed a turtle-like body plan before true turtles had fully evolved. They had wide, flat bodies covered with armor plates, and their ribs were expanded to form a basket-like structure similar to a turtle's shell. Scientists have found several different species of saurophargids, showing how this group experimented with the turtle design. Some species, like Sinosaurophargis, were more heavily armored and turtle-like than others. These animals probably lived in coastal waters, moving slowly along the bottom and using their armor for protection against predators. Another fascinating group that independently evolved turtle-like features were the Placodonts, which lived from 245 to 201 million years ago. These marine reptiles took the turtle design in some remarkable directions, developing unique adaptations for life in the sea. The Placodonts showed incredible diversity in their body plans. Some species, like Placotis, had massive crushing teeth perfect for eating hard-shelled prey like mollusks and crustaceans. Others, such as Placocheles, developed long beak-like snouts for probing the seafloor in search of food. Many Placodonts had complete shells covering both their backs and bellies, convergently evolving structures very similar to turtle shells. One of the most extraordinary Placodonts was Henodus. This unusual creature developed a filter-feeding system similar to modern whales, along with a sharp serrated beak for scraping algae off rocks, remarkably similar to how modern green sea turtles feed. This shows how the turtle body plan could be adapted for various feeding strategies. Much later in Earth's history, around 48 million years ago, a group of mammals called glyptodonts evolved to look remarkably like giant tortoises. These relatives of modern armadillos provide another excellent example of convergent evolution. Glyptodonts had huge domed shells made of interlocking bony plates, similar to turtle shells but evolved independently. Some species like Dodecurus grew to enormous sizes, over 3.5 meters long and weighing more than 2,000 kilograms. Unlike turtles, glyptodonts couldn't retract their heads into their shells, but they developed armor plating on their skulls for protection. Many species also had club-like tails that they could use as weapons against predators. Recent genetic studies have revealed that glyptodonts were actually nested within the armadillo family tree, showing how even closely related animals can develop dramatically different body plans. They survived until just 11,000 years ago, making them one of the most recent examples of turtle-like convergent evolution. No discussion of armored animals would be complete without mentioning the ankylosaur dinosaurs. While not exactly turtle-like, these dinosaurs developed heavy armor and wide, flat bodies that show some convergent features with turtles. One particularly interesting case is Leioningosaurus, a small ankylosaur from early Cretaceous China. Some scientists initially suggested it might have been aquatic like a turtle, based on certain features of its skeleton and the presence of fish bones found with its fossils. However, most experts now believe it was probably a normal land-dwelling ankylosaur, showing how careful we need to be when interpreting fossil evidence. The repeated evolution of turtle-like body plans teaches us several important lessons about evolution and adaptation. First, it shows that when a design works well for a particular lifestyle or set of challenges, evolution may discover it multiple times independently. The turtle body plan, with its protective shell, wide shape, and versatility for life both in water and on land, has proven to be an exceptionally successful design. Second, these examples demonstrate how similar environmental pressures can lead to similar adaptations, even in very different types of animals. Whether it's a marine reptile from the Triassic period or a mammal from the Ice Age, the need for protection and efficient movement can lead to surprisingly similar solutions. The story of turtle-like convergent evolution isn't necessarily over. As environments continue to change and animals face new challenges, we might see more examples of creatures evolving turtle-like features in the future. While we can't predict exactly what forms life will take, the success of the turtle body plan suggests it might remain a winning design for millions of years to come. Understanding these patterns of convergent evolution helps us appreciate the incredible adaptability of life on Earth. It shows us that nature often finds similar solutions to similar problems, even when working with very different starting materials. Whether it's a reptile, a mammal, or a dinosaur, the basic principles of protection, efficiency, and adaptation can lead to remarkably similar outcomes. As we face modern challenges in fields like engineering and design, these examples from nature can inspire us. The turtle body plan has been tested and refined through millions of years of evolution, proving its effectiveness in various environments and situations. Perhaps by studying these examples of convergent evolution, we can better understand not just the history of life on Earth, but also find solutions to modern challenges in fields like biomechanics and protective design.